Hello guys, welcome back to my channel. Today we'll be having a short discussion on the another type of anemia, which is hemolytic anemia. In this video, I will give you the brief information on the definition, the causes, what is the difference between intravascular and extravascular hemolysis, the discussion on different types of hemolytic anemia, which are hereditary spherocytosis, G6PD deficiency, autoimmune hemolysis, and the treatment of each of these three types. So let's start our discussion first with the definition of hemolytic anemia. So what is hemolytic anemia? It is a type of anemia which is caused due to destruction of red cells. As the name suggests, hemolytic. Hemo term is suggestive of RBCs. Lytic means destruction. So, from the name only, the definition can be made easily. It is a type of anemia in which there is destruction of red blood cells. But the important point is after this definition, which is in this, the rate of destruction of red cells is accelerated. There is increased destruction of red cells, but the ability of bone marrow to respond to anemia is unimpaired. This term is very important. It is unimpaired. That is why I have underlined it. So, according to this definition, there is destruction of red blood cells which is accelerated, but your ability of bone marrow to respond to this anemia, it is unimpaired, which means that there is no pathology of bone marrow. The bone marrow is normal. The pathology lies outside. There is destruction of RBCs, but the bone marrow is still capable of more and more production of red blood cells. The bone marrow is unaffected. So, this term is very important, unimpaired. This concept will be important if you will discuss further and you will compare this with your lymphomas and leukemias and megaloblastic anemias. So, till now, just remember that there is increased destruction, but the bone marrow ability to respond to this is unimpaired, which means it will increase its RBC production. The more the destruction, the more and more RBCs will be produced. So, thus, under maximal stimulation, the bone marrow is capable to increase its production about 6 to 8 times. This can be MCQ. So, it can increase its production 6 to 8 times, 8 folds more. Thus, what is retic count now? Retic count describes what? It describes how fast new RBCs are made. So, the retic count in this hemolytic anemia will be increased. And this is how it is differentiating point from your last topic, which was megaloblastic anemia, in which due to defective DNA synthesis the retic count was low. So this is how the laboratory findings, on the basis of your CBC and your peripheral blood smear picture, which I will describe later. So in CBC, how will you differentiate between the two anemias, whether it is megaloblastic anemia or the hemolytic anemia? It is important that in hemolytic anemia, the retic count is increased. Why? Because I've told you in the definition of this anemia that the ability of bone marrow to respond to anemia is unimpaired. Thus, it will increase its production, and more production of RBC means increased retic count. So, that is how it is differentiated from megaloblastic anemia.